1.6 grams. So somewhere between there is the bulk density of the soil, roughly 1.6 grams per cubic centimetre. And what that means is how much water can go through, how much pore space there is really. So therefore how roots can grow, how water can be held within the soil. Because like you guys were just saying, so in a soil you've got roughly 50%, well, roughly 40% mineral content, and then a 5 to 10% maybe organic matter content, and then the rest is split roughly half between water and air. So this is kind of a measure. If you're looking, this is a physical measure. So I'm going to Australia to do my thesis soon, and this will be one of the soil indicators I look at. This is a physical soil indicator. So if you've got good bulk density, if you've got a bulk density of less than 1.6 or something, it means it allows good movement of water, good movement of roots as well. The trick though is testing this, and you'll know the volume of this ring. The volume of this ring, you have to measure. That's just pi r squared times the height. So I think it's about 100 grams, and then your volume of the weight of the soil, you'll get it here, and this is wet. This is still with air and water in it. You then have to dry that soil sample, divide it by the volume, and it'll give you X amount of grams per the volume that you have, and then it's reduced to 1 point whatever per centimetre cubed. The trick though is getting a soil that is, you have to push this in really gently, so that the soil that's captured within there is not disturbed, that you haven't pressed on it, that you haven't made it more bulk than what it actually is in its steady state. And this is the tough part. So it's easy to explain it, but it's really hard to get. I tried one there, but it was a bit crumbly, so I'll try another one. Somewhere there's a nice flat surface.
Maybe clean the surface.
It's not very complicated, but Pablo was working in Africa and had a very experienced guy that's very good. I'm not that guy.
I will tell the story of an assistant I had who was excellent doing this.
You need those people.
Alright, this is already crumbling on me, but then the trick is, this is even the harder part, is to get this out. Sorry.
No, it's okay.
Now this would be a pretty bad one. If I was in the field and I did this, I'd have to do it again. Because it has to be really flush, and as you'll see on this side, it already a bit fell out. But then once you've got this, you want to weigh, and any gravel you want to take out as well. But this then would be roughly your sample. Once this is dried, your weight would be over that, and you work out then. It's a good physical indicator, It's a pretty common one that they use. It's not one that a farmer can do really quick in the field, and these are the ones that people like to use.
And this is important as well, because when we think in terms of stocks of carbon or stocks of nutrients in the soil, we express them as percentage per kilo of soil. And if the soil is looser or more compact, the amount of kilo of soil per volume is different. So nowadays, it is common practice to express all stocks corrected by bulk density, so you can compare soils. So you say, well, I have 1% carbon up to 1 meter, just as an example. And a sandy soil is not the same as to have an average 1% up to 1 meter on a clay soil, because the amount of soil present is different.
Of course, if you've got sand, it's a bigger particle, than a clay, so you'll generally have better drainage and bigger pores, but then with clay you have much smaller pores and therefore better capacity to hold water or nutrients. So you want to mix between that. That's why silty loam clays are generally the best soils.
Great. Thanks.
Thank you.